Welcome to this tutorial on measurements and labeling in JMOL application. In this tutorial, we will learn to create models of carboxylic acid and nitroalkane. Label atoms in a model with symbol and number. Measure bond lengths, bond angles and dihedral angles. To follow this tutorial, you should know how to create and edit molecular models in JMOL application. If not, watch the relevant tutorials available on our website. To record this tutorial, I am using Ubuntu operating system version 12.04, JMOL version 12.2.2 and Java version 7. Let's go through the steps on how to build a carboxyl group using this animation. As an example, we will create a model of ethanoic acid, commonly known as acetic acid. We will begin with a model of ethane. We have to convert one of the methyl groups to a carboxyl group. Substitute two hydrogens attached to the same carbon atom with hydroxy group. Delete hydrogens attached to one of the oxygen and carbon. Convert carbon-oxygen bond to a double bond. Methyl group is converted to a carboxyl group. Observe that ethane is converted to ethanoic acid. We will follow the above steps and create the model of ethanoic acid in JMOL application. This is a model of ethane on JMOL panel. Let us convert a methyl group to a carboxyl group. Select oxygen from the model kit menu. Click on the hydrogens attached to the same carbon atom. Now check against Delete Atom option in the Model Kit menu. Delete the hydrogen attached to the oxygen and also delete hydrogen attached to the carbon. Then let us introduce a double bond between carbon and oxygen. So check Double option in the Model Kit menu and click on the bond connecting carbon and oxygen. We have a model of acetic acid on screen. Do the energy minimization to optimize the structure. We will follow a similar strategy to create a nitro group. Here is the JMOL panel with a model of ethane. Now let us convert this molecule to nitroethane. Click on the Model Kit menu and check against nitrogen. Click on the hydrogen atom in the ethane molecule. Nitrogen atom is represented as blue sphere. Next, we will substitute two hydrogens attached to the nitrogen with a hydroxy group. Click on the Model Kit menu and check against oxygen. Then click on the hydrogens attached to the nitrogen. Delete the hydrogens attached to the oxygen atoms. Open the Model Kit menu and check against Delete Atom. Click on the hydrogen attached to the oxygen atoms. Now we will introduce a double bond between nitrogen and oxygen atom. Check the double option in the Model Kit menu. Click on the bond connecting nitrogen and oxygen atom. This is a model of nitroethane on the panel. As an assignment, create models of 1-butanoic acid and ethyl acetate. Optimize the structure by doing energy minimization and save the image. Your completed assignment should look as follows. Let's go back to the JMOL panel. This is the model of 1-butanoic acid on screen. Let us learn to label the atoms in the model. We do this with symbols corresponding to the element and number. Open the display menu and select Label from the scroll down menu. Select Symbol option to label all the atoms in the symbol corresponding to the element. Name option will give both symbol and the number. Number option will give only numbering of atoms. One can erase the labels from the model using the None option. We can also use the pop-up menu to do all the above modifications. Right-click on the panel to open the pop-up menu and check the various options. Distance between any two atoms in a molecule can be measured using Tools menu. Before we measure, open the Model Kit menu and click on Minimize. Energy minimization is now done and the model is in its most stable conformation. Now click on Tools menu. Select Distance Units. Select options from the submenu according to the requirement. For example, I will choose angstroms. So the bond lengths I measure will be in angstrom units. Click on Rotate Molecule icon and bring the cursor to the panel. I will measure the distance between atoms 9 and 4. First double click on the starting atom, which is atom number 9. To fix the measurement, double click on the ending atom, which is atom number 4. The bond length is now displayed on the screen. Let's do some more measurements of bond lengths. Let's measure the bond length between carbon and oxygen double bond. So double click on atom number 5 and bring the cursor to atom number 7 and double click on it. Similarly, let's measure the carbon and oxygen single bond distance. So double click on atom number 5 and bring the cursor to atom number 6 and double click on it. We can see that on the panel all the bond lengths are displayed. We can also measure bond angles and dihedral angles in a model. For example, we will measure the bond angle between atoms 9, 4 and 1. Double click on atom number 9, then click on atom 4. To fix the angle measurement, double click on atom number 1. We can see the bond angle displayed on the screen. Let's measure another bond angle, say between atoms 1, 5 and 6. Double click on atom number 1, click on atom number 5 and lastly double click on atom number 6. Measurement of torsional or dihedral angle involves 4 atoms. So we will choose atoms 8, 4, 1 and 2. For measurement of dihedral angle, first double click on atom number 8. Click on atom number 4, then on atom number 1 and lastly, to fix the dihedral angle measurement, double click on atom number 2. We can see the dihedral angle measurement displayed on the screen. Values of all measurements made can be viewed in a tabular form. Click Atom to Measure Distances icon in the toolbar. Measurements dialog box opens on the panel. It has a list of all the measurements made so far. We can now save the image and exit the application. Let's summarize. In this tutorial, we have learned to create models of carboxylic acid and nitroalkane. Label atoms in a model with symbol of the element and number. Measure bond lengths, bond angles and dihedral angles. For the assignment, create models of molecules with single, double and triple bonds. Measure bond lengths between the carbon atoms and compare them. Watch the video available at this URL. It summarizes the spoken tutorial project. If you do not have good bandwidth, you can download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials, gives certificates to those who pass an online test. For more details, please write to contact@spoken-tutorial.org. Spoken Tutorial project is a part of the Talk to a Teacher project. It is supported by the National Mission on Education through ICT, MHRD, Government of India. More information on this mission is available at this link. This is Snehalata from IIT Bombay signing off. Thank you for joining.